Okay, so let's look at our first example here of integration by parts. So remember, the idea is this. Well, what does this actually mean? That the integral of u dv is equal to uv. Is when we have an integral that involves a product like this that can't be integrated by some kind of substitution uh, or one of our other techniques, then we are going to let one part of this stuff inside here be u, and the other part be our dv. The idea here is whatever parts of the expression inside the integral that we let dv, we want that to be something that's easy to integrate. It's easy to integrate. That's one criteria we want, because if it's a lot of work to integrate, then maybe that's not such a good idea. We also like u to be something that's easy to differentiate, because what's going to happen is once we've done this, we integrate this to get our v. We will differentiate this to get du. Then we're going to be working with this integral. So the hope is that if we can have this where it gets to be something of lower degree and easier integral, that's a definite idea that we're looking for here. So we're going to write this eventually as uv, once we figure out what u and v are, minus the integral of v to u. So, so we're going to be examining this and trying to think, okay, what should we let u be? What should we let dv be? Okay, well, for both of these, e to the x is easy to both integrate and differentiate, and x is both easy to integrate and differentiate. But generally speaking, if they're involved, positive powers of x are often good choices for you. And that's because as you keep taking derivatives of a positive power of x, well, eventually they're going to disappear and be just a constant, right? Like, for example, here the derivative of x is just 1 dx. So he's going to actually disappear from the problem. So that's kind of one thing we look at. Positive powers of x are often good choices. Now, there's sometimes something that's a better choice, and we'll see some examples later on. But positive powers of x are often good choices because eventually, as you do the derivative of that over and over again, you're eventually going to get down to a constant. Yes, that means sometimes you may have to do this integration by parts more than once for a certain power of x. So we begin here by, again, setting some of the stuff inside this integral to be u, and some of it to be e to the x. So here we'll start by letting u be x, and I'm going to let the rest of the stuff be my dv. E to the x dx. I then differentiate implicitly here and get du would just be 1 dx, or just dx. And over here I integrate. Integral of dv is v. Integral of e to the x dx is e to the x. Yes, it's plus a constant, but we don't worry about the constant right now. And the constant will come in later on. Okay. So now we know what v is, and now we know what u is, and so now we can use our formula and say, hey, our integral over here will be uv So x e to the x minus the integral of v e to the x du, which in this case is dx. And so you can see by this change, we've managed to get from an integral, having to evaluate an integral that has a product, x times e to the x, to having to evaluate an integral that's actually pretty easy to do, right? We just have this simple integral e to the x dx. So we integrate that. So we get x e to the x minus e to the x, and then plus our constant of integration. Okay, so again, when we're able to do it, positive powers of x are often a good choice. Because at least they'll eventually go down to things small enough. And again, the formula is the integral of u dv is uv minus the integral of v du. And that's just coming from taking the product rule all right, and solving for that one piece. All right, so that's why we have the uv on the other side, and then we're subtracting the v du off on to the other side. Okay, so that's why it's uv minus v du. Okay. So again, positive powers of x, good choice because their derivatives, if you have to do this process more than once, will eventually reduce down to a constant, which will leave you with something you can integrate. Okay, so that's it for this example. We're going to continue in the future videos looking at some more examples. There are some things that come up, some little issues that we sometimes will run into as we're looking at this integration by parts. But here, this is a good start for our first example here. So let's wait and move on to our next ones.